There's a couple of things I was going to chat on, I guess a little bit of background to follow on from what Rowan was saying this morning. Obviously there are some changes coming in for labels, and I guess some of that pressure has come from spray drift, and we've had some pretty big events in some areas across the country in recent years. A little bit on the background why, and I guess things we can do to reduce that, and the implications for advisors to a certain extent. So a bit on why there's been more, a bit on the damage, and how we can reduce the problem, and any sort of questions you guys want to throw in as we go. I just put a reminder at the start is this is what growers are trying to achieve, and that is to get control of weeds. And if I looked at the factors that affect it, timing is probably going to be one of the most critical things, and obviously the ability to get over the country in a timely manner is important to them, which drives them into operating bigger, wider, faster machines, that type of thing. In terms of efficacy, rate of product's always going to be, after timing, these two are really tied in, then your water volume and adjuvants. And your nozzle type, height and speed all contribute, but they're probably lower down in order of importance compared to these from an efficacy point of view. Whereas from a drift point of view, your timing in terms of weather, nozzle selection and height, and that are big contributors. So it's really a balancing act to get the best of both. And certainly a lot of the trial data will show in recent years that we can probably push that droplet size a bit bigger in terms of efficacy, which really does contribute to minimising those losses, and certainly will feed into some of that APVMA requirements for larger droplets on labels if we want smaller buffers. So in terms of the drift itself, I think that's quite different. Obviously the increased adoption of min-till has meant more herbicide spraying in summer, and certainly in those areas where you've got diverse cropping systems, broadleafs, cotton, grapes, other hort crops, that summer spraying and more of it becomes a challenge. The thing that's really changed, probably these two in recent years, in addition to spraying more, our capacity has just gone through the roof. I look at 20 years ago when I first started looking at sprayers, guys ripping out 30, maybe 40 hectares an hour were doing really well. We've got guys that are ripping out 100, 120 hectares an hour now. And you take a 36 metre machine, drive it in the mid 20 k's an hour on decent runs, and you can rip out 100 hectares an hour quite comfortably. And if you think about it, that's 2-3 times the amount of chemical release per hour. So just on a risk point of view, the way we do it now is much higher. But the speeds and the machine setups in combination with that in terms of higher booms, higher travel speeds, all of those things contribute to more chemical in the air as well. And I guess the addition of guidance to the equation has meant that in the last decade we've actually got a lot of spraying going on at night. And that's under totally different conditions to daytime. What can happen to the movement of products overnight, it'd be very, very different to daytime. So they're all factors which lead to increased risk if things go wrong. In terms of the damage, the kind of damage we've seen in recent years, when we do get a decent rift event, usually it's quite big. Our experience normally is a bit of stuff goes through the fence, touches up the neighbour's sorted out. It's happened for years. Daytime stuff rarely will go more than 400 or 500 metres downwind if it's under neutral, reasonable wind conditions. Whereas, in the past couple of years when I go look at stuff, I'm looking at whole fields, 150, 200 hectares, or whole farms that are snotted with a uniform dose. And I've seen that in particular areas and landscapes. And so it's not just the normal drift that moves across the fence or maybe a little bit further under inversion. It's a saturated air mass that's obviously settled in a particular point, which looks a lot like the old-fashioned high volatile type drift events. But I see it with non-volatile products as well. So I don't believe it's a volatility issue, I think it's just the conditions when we spray. And I'm not anti-night spraying, I don't want that message to come across. I'm anti-spraying when there's no wind. And so there's a lot of times at night from an efficacy point of view, in terms of humidity and temperature of plant response, are always going to be much better from an efficacy point of view. But the risk when the wind speed drops overnight is totally different to the daytime, and that's what I want to focus on. So I guess it's really tied in with the idea of an inversion. Everyone's heard of inversions. Normally temperature decreases with height. Inverted just means the opposite. It's actually warmer up high than it is close to the ground. So you can get upper level inversions. and you can get inversions close to the ground. And the upper level stuff is usually the influence around sunset, early evening, and when your wind speed drops. That's an upper level inversion, typically cutting you off from your normal weather pattern winds for a while. You can also get the same effect down closer to the ground, and this is just trying to show that the temperature's higher up here than it is down. So overnight, your cool air, obviously being closer to the ground, will drain like water, and you can get cool air slipping in and creating low level surface temperature inversions as well. And they're ones that are particularly dangerous for spraying. So higher level stuff which will affect you on a landscape level and your local winds. And then overnight towards early morning, particularly those couple of hours before sunrise, can be a really high risk for stuff close to the ground. And what can happen in that situation is that your air close to the ground can actually separate out into layers or laminates. And everyone's probably seen that with fog layers. Your headlights hit them, you see the fog, you see the clear, you see the fog. That's just stratification in the air. And that fog's probably 30 micron or smaller water drops trapped in that layer of air. And they'll actually stay there typically till the inversion breaks. So during the daytime when you've got heat in the ground and air movement, your air will mix and anything you put in the air typically will come down quickly, so you can predict that by the time you get a certain distance downwind it will dilute it. And that's what the buffers on the labels are about. At what distance would you expect probably 90% of the time it will have diluted by? You know, the buffers on the labels won't handle this sort of condition. You can't predict how far that will go because this will be a laminar flow, might travel at 1 or 2 or 3 kilometres an hour. We did some trials last week up near Moree where we had laminar flows of 11 or 12 k's an hour overnight. So it means for each hour, that chemical in the air could end up a long way away, a couple of k's, maybe further depending on the conditions. So low wind speeds overnight, particularly dangerous. The label says a minimum of 3 to 4. I don't know if that's enough overnight, but certainly during the daytime it is. So as a rule of thumb for the guys that are spraying at night, I think you get the start of the evening where your wind speed tends to drop, that's an inversion effect. And depending on how far you are from the coast, you may get sea breeze or effects coming back off ranges that mix the air, that's probably okay. You start getting after midnight, if the wind speed drops and picks up again, I'd be very cautious of that wind speed picking up again in the wee early hours before sunrise. It's more likely to be laminar. And even when you think there's no wind, it's probably likely doing 1 or 2 k's an hour and still carry chemical at this sort of distance. I guess the key for that is knowing where you are in the landscape and where things may run from the grower's place, and wherever water will go is where this stuff will drain to, because the cold air will behave just like a fluid. So, I guess that's what I'm trying to show here, and it's the need to know what's lower down in the landscape from wherever you're spraying, because that's where it'll end up. I guess these are the areas, particularly on bigger floodplains, where you've got your higher value crops typically growing where they can harvest water. Obviously you can harvest water there, it's a drainage point, and that's where the air may end up. So looking at it on a landscape level, you can kind of predict where some of this stuff may end up. I don't think it's a single person responsible. It's more likely where you get a break in the weather, you get quite a few guys in an area all spraying at the same time, may end up with those sorts of problems. But if you spray within the label parameters, you wouldn't be spraying under that sort of wind speed anyway. I guess my cautionary statement is that if we keep having these sorts of issues, the regulators have done nearly as much as they can with the labels. The next step is to restrict access or restrict it on an area by area basis depending on the risk of that area. That's where I don't want us to get to. So I don't think it's a Phenosy issue, I think it's an issue for all products. So what can we do to reduce the problem? Well, obviously the labels do have statements in terms of wind speed and also in terms of droplet size. There's minor changes coming in there. The wording is more likely to say, instead of saying smaller than coarse or very coarse, it'll say coarse or larger. Some labels will say medium or larger. So just check the wording on those. Wind speeds on some of those products that were restricted to 15 may go up to 20, but will have a no spray zone. That's a downwind buffer between you and something considered to be sensitive on the label. Has everyone had a look at those examples? Nicholas put some of them up this morning. The other thing that's coming in on the labels that's probably important for you guys, particularly any company that gives logs out for, or record keeping out for clients to use, in that those new record keeping requirements form a part of the label of some products. And I guess in New South Wales, under the Pesticides Act, you have mandatory record keeping anyway. But the difference between what's on the label and the Pesticides Act will be a couple of things. One is that the exact details of the nozzle will be required, and that's not covered well under the Pesticides Act. So you need the fan, or the nozzle type, the manufacturer, the model, the fan angle, the size, and the operating pressure. That's actually different to your state legislation at the moment. So if you've got record keeping sheets you give out, make sure that you have somewhere to cover the full nozzle details. The second point there is that the trade name really should be covered. A lot of growers will just write glypho or will write Roundup regardless of the glyphosate product they're using. The potential with this system is that depending on what's in the drum, in terms of formulations or other effects, you may end up with slightly different buffers, or if there's a different mix in it. So you may actually end up with different requirements for different actives. So it's kind of reminding growers to get back into the habit of checking labels, but also being aware yourselves what's on the label of the product you're recommending, whether the droplet size has changed, whether there's a buffer there, because we've all got shared responsibility under the Pesticides Act here. So whatever you advise a grower to do, you're tied up with. At night, I don't know what the buffer should be. It's probably 2 or 3 Ks minimum for each hour you start spraying before sunrise if the wind drops, because that's probably how far it will go before the inversion breaks. As I said, some of those areas where we had big damages on cotton, north of Weewar, out towards Pilliga, those sorts of areas, they got 8 to 10 hours of stability overnight. Some of that product movement could have come within probably a 10, 20k radius easily under the conditions they have. As I said, there's nothing on the label that will stop that at the moment. It's more about educating our growers and operators about when they're spraying in the highest risk situation. I think if someone's going to go out spraying at night, I'd want them set up for the worst condition I'd expect, not the best. In other words, pick the biggest droplet that will give you efficacy or control in the paddock, and minimise that airborne fraction as much as you can. And there's a number of things you can do to do that. The other thing I think, make use of forecasting tools. Obviously, New Farm's got their spray wise, and they've got the Agricast and a new Agricast is a Pro, the new version of it, or updated version. I mean, both of them will give you a forecast for the next couple of days on what to expect. That's the old Agricast, sorry, I haven't updated it. Or the New Farm, which gives you a spray plan for the next couple of days in terms of rainfall, inversion risk, a number of things. I think every tool we can give a grower to make better decisions is useful. Obviously, forecasting is one of those. Monitoring conditions. I mean, the labels say that the wind speed, temperature, humidity, all those things that form new parts of label requirements have to be measured at the site of application. So, most clients have to at least have some form of a handheld weather meter. I guess the next step up from that, something like one of these fellas, an onboard weather station. Has anyone here seen watchdogs similar? Basically, the basic handheld unit, you get them in a series, you've got to jump out, take a measurement. Some will do delta T. You can get the next level up from that, which will actually log, record stuff. The one I've got will download it to a handheld, sort of little Bluetooth cradle. Will download the data to the computer. You can also get them with wind vanes and digital compasses in now, so you get wind direction as well. This fella here actually has a built-in GPS, and so it gives me wind direction, speed, temperature, relative humidity, delta T, whatever I want on the screen while I'm driving, like live data. And I can choose to log that at whatever period I want, or just record it as I go. Gives me a timestamp, a GPS position, when I started the paddock, when I finished, and when I want to take records in between. So this sort of stuff's, I've probably got 25, 30 contractors that I deal with that run all this gear now, spray contractors. So during the daytime, I think you can probably do it every load. and if you can visually pick up something changing in between, you make a measurement then. At night, I think you need much more regular feedback. As I said, you can spend $3,200 on this to tell you when the wind drops, or you can spend about $30 and put a fiberglass fence drop and a ribbon out in front of the spotlight, because it'll either be blown like this or this when the wind drops. So there's visual indicators your growers can use to assess wind speed at night. All of them work, it's just this one saves you recording a lot of stuff. I'd still write it down, but it's there logged and you can download it. Delta T is another one. It's been a message that's been really well sold, and I think it's probably partially responsible for the increase in night spraying. I agree that up here at Delta T is less than 2. There's a high risk of drift from droplet survival, and typically you'll get that early in the morning. The 2 to 8 thing, I think it's based on droplet survival of fine droplets in the air. So anywhere along the same Delta T, same rate of evaporation. 2 to 8 is a fine droplet recommendation. I'd be working on 2 to 10 for medium and probably up to 2 to 12 for coarse as a guide. But for most guides, are we worried about humidity in the air or humidity at the target? Because once you get to coarse droplets or bigger, the majority of them are going to end up at the deck. I'm more interested in droplet survival and plant stress down there. So as a guide, the 2 to 8 I think is ridiculous for anyone that's using coarse droplets. And I think it will force people into more spraying under unsuitable wind speeds in the evenings. But to go from 2 to 8, 2 to 8 to 10 to 12 might be only an extra hour spraying during the day anyway. But if I could get that extra hour during the day and take it off that first hour or 2 hours before sunrise, I reckon it would reduce a whole heap of problems in terms of drift. If you're guys that are dealing with dust, wheel tracks, when do they go out and spray? And there's no wind, a couple of hours before sunrise, preferably when you had a decent tube. All indicators are really strong low level inversion. Good luck talking them out of doing that, because the efficacy then is usually best. But if there's anything susceptible downwind in the catchment from them, 1, it's off-label, those low wind speeds, and 2, it's really high risk. So maybe have a serious talk to those guys about ways they can minimise that risk. Boom height's one of those effects that I think, as a consequence of bigger, wider booms and travelling faster, boom heights are going up and up and up. And some of the data out of the UK, even at 16 kilometres an hour, if you raise your boom from 50 to 70 centimetres, potentially increase the amount of chemical you leave in the air 4-fold. If you actually have it up sitting around a metre, and there's a lot of guys with booms up around a metre in the air, 1.2, it's about a 10-fold increase. So you may have a coarse spray quality on there which has 7 to 10% driftable on average, but when you're up high and travelling fast, you might leave most of that in the air. A guy travelling at say 16 k's an hour, maybe an 18, 24 metre boom with flat fans down here at 50 centimetres, will leave less chemical in the air than one of you guys with a 36 metre boom in the mid-20s with coarse droplets travelling faster. So it's just a matter of doing lots of little things right. I know we're not going to stop guys from doing that, but if they are operating up there, they should be doing everything they can to reduce how much they potentially leave in the air. Maybe a course is not good enough for night spraying up there is what I'm saying. Certainly in our northern areas where we're dealing with in and around cotton, the guys are spraying at night are actually on extremely coarse droplets over summer now for their fully translocated products, like your Roundups and your 2,4-Ds. It'd be nice to reduce that summer weed burden where possible, so we actually minimise some of that spraying over summer. And I'm not trying to just slip that in, but my focus is on the spraying bits. Even your choice of not just nozzle, but what you put in the tank will affect things. When you look at a spray quality tank, it's predominantly just water through the nozzle. As soon as you put something else in the tank, you're going to affect the output. This is just trying to show, I guess, as a percentage of what comes out of the nozzle in the small stuff that can drift. A flat fan, a TT, and a low pressure air induction and air mix. These are actually run at 2 bar, which are less than ideal, and 250 mils per 100 is a pretty robust rate of wetter, but it's just an effect, to show an effect that a flat fan with water, stick a non-ionic in there, increase the drift potential. And that's generally true, and non-ionic will never reduce your drift, it's more likely to increase it. A true emulsifier, even some of your EC formulations will have an effect in terms of reducing drift. Some of your oils will also do that. So if I use this nozzle, I could say, yeah, if I put this adjuvant in there, I'll drop it. But an adjuvant's a bloody expensive way to change droplet size when you've got a choice of different nozzles. So normally your adjuvants should be there to make the product work better. Droplet size is a bonus. So you can do as much as you can with your nozzle selection. I find it interesting that your TT or your anvil style nozzles seem to be less affected by formulation effect than, say, your fan type, your air inductions, where instead of squeezing it through the hole in the end to make the sheet, it actually comes out and strikes the plate. So that style doesn't change its droplet size much. But even some of your air inductions have the potential, with the addition of non-ionics, to produce more drift than you predict from a spray quality chart. So my suggestion would be pick a nozzle that does as much as you can, and if you're in a tight situation, you have a choice of wetters, pick one that may not increase your problem if it's suitable for the job. As I said, pick the biggest droplet to provide efficacy, and we've been really lucky in recent years that the companies have generated a lot of data in terms of droplet size and efficacy in different situations. I ran 3 or 4 summers worth of trials in the north just comparing summer fallow type jobs, and we're just doing some stuff around Horsham and further south now, looking at different setups that I'll talk in a minute. But this is one of our summer grasses, south thistle, which is probably an issue everywhere. The 3 treatments on the left, and this is a lower stubble situation than you guys would be used to, but all at 50 litres per hectare. That's your grass and your broadleaf, a medium droplet, an air inducted coarse, and an extremely coarse. And one of the reasons why we run trials like this actually is, you probably heard from Rowan saying this morning that the APVMA generally for their models only has data up to the coarse to very coarse currently. And so if you run that nozzle 2,4-D, the predicted buffer will be somewhere around 300 metres. If you use an extremely coarse based on the Canadian data, that buffer would come down to around 100 metres as one of the DRTs. So we want to be able to demonstrate efficacy where we can with larger droplets to give people options in really sensitive areas. They're the same, basically the same sort of droplet size the next bit up, but it's 70 litres. And certainly we didn't see very many trends in terms of increasing volume as to improving efficacy. But the one thing I'll just point out is there's a new classification in spray quality coming out, which is called ultra coarse now, under the ASAE, which means some of your bigger ones that used to be extremely coarse are now classified ultra coarse. When I went back through all my trials, about 15, 16 trials worth, whenever I slipped into ultra coarse at whatever volume I did, there's a trend analysis down in efficacy. It doesn't turn up in single trials, but it's actually a trend across them. So your droplet size can be too big. And the other thing we found is when we take these really big droplets into heavy stubble situations, we get shadowing and problems. So normally I wouldn't, with a TTI, if people are familiar with that particular nozzle, I'd never go bigger than an 02. I'd never run them under 4 bar. My preference would be to run 015s on a narrower spacing to help overcome some of the shadowing issues you get with them. So big droplets aren't the only solution. They do create some problems on their own, but in some areas they're our only choice for guys that are going to operate big, wide, fast in high-risk areas. And the last one I'll leave you with before I take any questions, which is a picture I pinched from Croplands, but it's actually cut off the acknowledgement. Most of it's about common sense and watching what's going on. But I heard John Laws is back on the air, so he reminds us that common sense is a bit uncommon. I generally think most guys, when they fill a tank, will empty it before they stop, regardless of the conditions. And I'd rather set them up to minimise their risk as much as I can and still maintain efficacy. So happy to take questions, and hopefully I'm not scaring anyone. But just remember, Pesticides Act's at shared responsibility. You could get dragged into something if you know that your grower's not doing the right thing.
Speed compared to height, I've got a narrow boom spray that I run fast, but I try to keep it really low. Is that?
Height is a big consequence, so is speed. Speed will have a couple of consequences. One is at the nozzle itself.
So if you can imagine you're travelling that way, you've got downward velocity, depending on style of your droplet, the net movement's there. At some point the small droplets slow down, so they'll lose momentum. The fast droplets will actually accelerate. So the closer you can be to the target, you always get more deposition, big end and small end. So height, one thing it does do is the droplets slow down and become airborne quicker. So, you know, if I had a choice of speed and height, I'd actually look at lower height, would probably do more. The speed also has an impact in and around the machine between the chassis. So it depends on the design, how low the boom is below it or further back. If you can get out of that airflow that gets sucked up the back, that can be an issue. So, you know, if it's a big boxing machine, you can imagine air going over the top and underneath. It's like an aircraft wing creating lift. So what sort of machine is it?
Just a little spray coop.
Spray coop. Okay, you've got a bit more clearance off the ground, but your boom's still close to the chassis. An old one or a new one?
Medium.
Bigger?
Old.
Older. So while the boom's close to the chassis, there's still stuff that can get in the airflow. The bigger, the higher clearance, and the further back the lower the boom is, potentially you can reduce some of that out of the airflow. But I'd be more concerned about height than speed as a problem. But with speed comes a requirement to try and match that speed of your droplets to get issues, because with speed you'll get shadowing on interception on stubble, shadow and those types of issues depending on your droplet size and nozzle style. Long-winded answer for a short question, I know.
Bill, look, one of the things I often ask is anti-drift products, anti-drift adjuvants. If I haven't got my nozzle right, haven't got my timing right, haven't got my boom height or ground speed right, can I correct some of those things by using an adjuvant?
Whack something in the tank at the end, because you some of your drift reduction adjuvants will modify droplet size. The problem I've seen with them is if you compare the data, quite often they'll give you a bigger VMD, which is an average term. For me, it's half your volume is this droplets bigger and half your volume is this droplets small. You can shift VMD by producing a lot of bigger droplets without cutting down your driftable fraction. Some of those products we've tested in the past through the wind tunnel have just that. The VMD, this measure, looks bigger, but the small fraction hasn't reduced. And the problem with some of the polymers, particularly the longer chain ones, is the longer you put them through, mechanical pumps actually break down. So there are products that will increase droplet size or cut down stuff. They're more likely to be your true emulsifiers. They will do it. The addition of a stray oil will tend to increase droplet size to a certain extent, but it's not going to be the ideal situation to mix with gabies, your water soluble products. So the addition of adjuvants probably fraught with danger, and it's probably the last resort of scandal. I think you'd be doing a lot more by setting up the machine, selecting your nozzles, choosing a wetter that makes the product work better rather than inhibiting it. If it does all those things and controls droplet size, then you've got a winner.